Okay, and welcome back. Welcome to Chapter 3. And in Chapter 3, we're actually going to start doing math. You may have noticed that in Chapter 1 and Chapter 2, we pretty much just looked at ideas and concepts. We waved our hands a little bit about what we were going to do, talked about some terminology and gave some definitions. But in Chapter 3, we're actually going to start manipulating data sets, doing math, using formulas and that kind of stuff. We're going to start out in section 3.1, taking a look at this idea of the measures of center. So our key concept, our major idea is someone is going to hand you a data set. So someone's going to hand you data. Think quantitative data. So a big pile of numbers, right? And so let's say they gave you like 50 values. 50 data points, decent sized data set. How could you describe a typical or typical is the best word. How would you describe that data set with one number, a typical number that would describe the center of the data set? Some way to say, here's the middle with one number. And that really is the focus of this section. So in this section, we're going to focus on how to obtain a measure of center of a data set. Okay? So a single number that tries to describe the data set, and then we'll take a look at how will you interpret those values, like if someone was to tell you one of those. So a measure of center is a single value that attempts to describe the center or the middle of a typical data set, right? So kind of the idea of some are below this value, some are above this value, but it gives you an idea of what's kind of in the middle. Now, the first one of these we're going to look at is the mean, also referred to as the arithmetic mean, or because there are two other ones that use the word mean. There's a harmonic mean, and there's also a geometric mean. Now, these two we don't cover in this course. They're outside the scope of what we do here. But if you're wondering why they go to the trouble of specifically saying that this is the arithmetic mean, it's because there are two others. For our purposes, whenever you see the word mean, just think arithmetic mean. Don't worry about those because we're not going to cover those here. Okay? So you don't have to worry about what they are, or how one would use them, or what they mean, or any of that. Okay? All right. So the arithmetic mean is a measure of center that is found by adding all the data values together and dividing by the total number of data values. So when you hear the word average, that's what we're doing here, except for this is a stats course. So we don't call it average. We give it a fancy stats name. We call it the mean. And that's how this works. Okay? There are some important properties. There are reasons to use the mean. Right? One of the reasons to use the mean is samples drawn from the same population tend to vary less than other measures of center if the measure of center that you calculate is the mean of that data set. Now, what the heck does that mean? What is that statement supposed to tell me? Right? Well, suppose that you have a population, whatever that population is. Now, remember, populations, that means all. Of the elements. So if I go back to my favorite example, my 12-ounce Coke cans, the population would be all of the Coke cans ever produced by that filling machine. All right? A sample, remember, that's just some of the elements. So that will be some of the cans. Now, there is a mean for the entire population of cans. If we could possibly measure every single can that had ever been produced by this machine, find out how many ounces of soda were in it, and then find the arithmetic mean for that population, I would know the mean for the soda cans. I would know the population mean. The problem is we can't do that. We can't measure every single can, so we take that sample. And when we take some of those elements and we find the mean of some of those elements. And if I do that today, and if tomorrow I do it again with a different sample, and if the next day I do it again with a different sample, what's going to end up happening is all of those sample means will vary less than other measures of center. So whatever number I get today, the number I get tomorrow won't be that different. And the number I get on, what day is today? Tuesday, Wednesday, and Thursday, and Friday, all those values won't be that different. And that's a good thing. We like consistency. Another property is it uses every data value. High, low, outliers, whatever, it uses every data value in the calculation, right? Now, that's a property, but it's also a disadvantage because one extreme value, one outlier, can change the value of the mean substantially. What does that tell you? Okay, well, let's give you an example. Suppose that there are 3 friends, right? So we've got 3 people, 3 elements in our data set. And to keep things simple, suppose their salaries are $49,000 a year, $50,000 a year, and $51,000 a year. Okay? Well, the mean salary among those 3 friends is $50,000 per year. Because if we add those 3 numbers together and divide by 3, we get 50K. Suppose that a new friend joins the group, a 4th friend, and let's say that that 4th friend makes $12,000 a year. Now suddenly, if we calculate the mean for this new group, and let me grab my calculator to do that. So 12 plus 49 plus 50 plus 51, and then divide that by 4. Now I get a mean of 40,000, 40.5 thousand. Did you notice how adding one person and that one person being an outlier drastically changed our mean? If their friend wasn't an outlier, like if instead of 12 they made 42,000, then yeah, the mean would have gone down, but it wouldn't have gone down drastically. So one of the downsides, one of the disadvantages is that outliers can really affect your mean. We have a term for that, right? A statistic, again, I keep thinking that's a highlighter when it's not. A statistic is said to be resistance if outliers don't mess it up. If outliers do not cause it to change very much. Okay? If an outlier causes it to change, we say it's not resistant. So given that definition, we would say that the mean is not resistant. Because resistant would be outliers don't change it, outliers changing it, not resistant. Right? All right, there's going to be some notation that we're going to be using when we talk about the mean. I'm hoping that you've seen some of this before, maybe in a math class, like this guy. That's the capital letter sigma, and that is an operator in mathematics. An operator is a thing that tells you what to do. You know what these are? Addition symbol, division, subtraction symbol, division symbol, things like that, square root symbol. Those are operators. They are a symbol that tells you to do something. The sigma is a symbol that tells you to do something. It says to take the sum of a bunch of things. Right? X is going to be our variable to represent the individual data values. N is going to represent the number of data values in your sample. Capital N would represent the number of data values in a population. Again, note the difference between those two right there. Samples, sum, lowercase letter, population, all uppercase or capital letter. Okay. X bar, X with a little line over it. X bar is the mean of a set of sample values. So from a sample, we get a mean, but we call it X bar. From a population, we get a mean, but we call it mu, or the Greek letter. It looks like a U with a tail on the left as well, the Greek letter mu. Okay? And we put it all together, you'll see this kind of a formula written. And so what does that mean to do? Well, let's zoom in on it. That tells me to add. That tells me to add up all my data, and then that tells me to divide by n. What was n again? Oh, that's a lowercase n, so that's the number of data points. So that's what's going on there. Now, contrast that with this one down here. What's the difference between those two? Well, the numerator is exactly the same. It says add up all the data, but now we're dividing by capital N, which is just the number of data points, but now it's a population instead of a sample. So I calculate these things the same way. I add up all the data points. That's what the numerator says. Add up all the data and divide by how many I got. I call it mu if my data is the population. I call it x bar if my data is a sample. And the reason we have two different things is because we want to be able to tell the reader two different things. If I told you that x bar was 43, or if I told you that mu was 43, I'm kind of telling you the same thing, but not. I'm telling you the mean is 43 both times, but over here on the left, I'm telling you the mean is 43, but it's the mean of a sample. Whereas over here on the right, I'm telling you the mean is 43, but I'm telling you it's the mean of the population. And what should we take from that? Well, where did the data come from? And how do I tell the reader, how do I tell the person interpreting this measure of center that my data came from the sample or that my data came from the entire population? Well, I got a quick, easy way to do that. I use a different symbol for each one. All right, so here's our first example. We're going to take a look at this one. I have the following measures of data speeds for smartphones from Verizon. Right? So I want to find the mean of the 5 data speeds, blah, 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 and blah, blah, blah. Right? Now I'll show you 2 ways to do it. First off, we'll do it by hand. Okay. Now, nothing in here tells me that this is the entire population. So I'm going to assume this is a sample. And I'm going to say that the sample mean is going to be found by taking the data points, that's a 38.5, plus a 55.6, plus a 22.4, plus a 14.1, plus a 23.1, and then we're going to divide it by 5 because there are 5 data values. Now that looks like calculator work to me, so I'm going to grab my calculator and I'm going to say 38.5 plus 55.6 plus 22.4 plus 14.1 plus 23.1, and so I get a grand total of my numerator being 153.7 all over 5. So I get that my sample mean, so 153.7 divided by 5, and I get 30.74. And these were what? Megabits per second? MGBITS per second? All right, so then what is this number supposed to tell me? Oh, okay. I had a sample of data, and I found the arithmetic mean to be about 30.74, well, to be 30.74 megabits per second. So a typical or a central measure of speed for Verizon smartphones would be 30.74 megabits per second. Okay, I said to show you two ways to calculate this. That was one, that's the by hand method. And for a data set this small, 5 data points, doing it by hand is not a big deal. But I'd like to show you another way to do it using the calculator. Okay? All right, so first things first. I have a data set. I want to put that into the calculator. And I'm going to put that into the calculator by putting it into a list. Okay? So if you look on the keypad, you see where it says list right there? Right above the stat key. Okay, now if I press the stat key, it doesn't give me that, but it does allow me to edit my lists. So I'm going to press stat, edit, option 1 there, and it brings me to my stat list editor. Your stat list editor should say L1, L2, L3 across the top. It may or may not have numbers in the list. If you've used it before, if it's been used before, it would have those. If not, you'll be blank. I've got data in my first list. I want to clear that data out. So I'm going to use the keypad over here to scroll up until the L1 is highlighted, press clear, and press enter. Okay? If at some point in time you make a mistake and press delete, see how L1 literally left? I can fix that. I go back to the stat button. I go to setup editor. I press enter. It says done. Now if I go back to edit, my L1 is back. Okay? All right, so now I'm going to take the data set and input it into list 1. So 38.5, enter, 55.6, and then enter, 22.4, and then enter, 14.1, and then enter, and then 23.1, enter. So my data list is in there. My data set is now in list 1. And now I'm going to ask the calculator to find the mean of list 1. So I'm going to go back to that stat button. See how there's 3 drop-down menus across the top? Edit, calculate, and test. I'm going to scroll over to calculate. And I am going to ask the calculator to perform a calculation of one variable statistics. This is a data set of just one variable. Right? 2 variable is when you have x's and y's. Remember the scatter plot data? That kind of thing would be 2 variable stats. This is just a list of numbers. This is 1 variable stat, so I'm going to press that up. And then it's going to ask me some questions. It's going to ask me, first off, where did you hide the data set? What list did you put it in? Now I put it in list 1. It says list 1, so I'm good. If I had put that data somewhere else, down here on the keypad, do you see above the 2 in blue, there's a little L2 for list 2, and above the 3, there's a little L3, and above the 4, there's a little L4. If I had put the data somewhere else, I'd change it down there. Like if I wanted to change it to L2, I'd press the blue key and then that, and it would change it to L2 for me. Okay? Now, our data is in L1, so I'm going to change it back. Frequency list. I don't have one of those. My data is not a frequency distribution. My data is just data, so I'll leave that blank. I'll go down and say, please calculate it for me. And it runs, and look what it gets for that first option right there. It tells me that X bar, the sample mean, is 30.74, which is the exact same value we got. Now, I know what you're thinking. That was a lot of work, and this was pretty easy, and it was. For 5 numbers, I don't know the advantage to this. For more than 5 numbers, it will be advantageous. When you've got a 20 data point list, I don't want to do it by hand. Okay. There are lots of other things being presented on the screen. You'll notice that the second line is the sum of the x's. That's that 153 that we got right there in our numerator. Okay. The third line is the sum of the x squared. So it took every single data value over here and squared it for some reason. SX, sigma x, n is 5 down there, data set, min, r. And all of these things are things that we will use at some point in time this semester. So that one variable stats thing is something we'll be doing. Okay? All right, so I'm going to just click out of here. Okay. Now, there's a caution here just because the word average or the term average, we try not to use that in stats because the word average doesn't really have any meaning statistically. So we say the mean or the arithmetic mean. It's very, very rare for you to see a statistician, someone who's a professional in this community, use that term average. It's just not used. Okay? It's just one of those things. You've used this word for a long time to do that calculation right there, where you add them up and divide by how many you got. And now suddenly I'm saying to you, oh, no, don't use the word you've been using all your life. Use the word if it makes you happy. But just know that when you're reading the homeworks and you're taking the tests and you're reading scientific journals, because I'm sure you do that on the regular, you're not going to see that word. You're going to see the word mean. And your job is to know, oh, that's that thing I call average. All right. Our second measure of central tendency, our measure of center, is the median. Right? The median of a data set is the middle value when you order the data in increasing or decreasing magnitude. Okay? So if you listed the data from smallest to largest or largest to smallest, doesn't matter which way, and you find the one that's in the middle, you'll get your median. Okay? So I'm going to go back to my first example of my three friends, the 49, 50, 51. That's the middle. So that would be our median. It's literally the number in the middle. You list them from smallest to largest. Most common to list them from smallest to largest increasing. You could do it decreasing. If I switch the order of this and said, no, it's 51, 50, 49. That's still the median. Right? But it's less common to see it decreasing order. It's more common to see the data set in increasing order. The good thing about the median, an important property of it, is it is resistant. If I change this 49 to a 3, we get rid of our $49,000 a year friend and bring in a $3,000 a year friend, 50 is still the median. It isn't affected by that outlier. Right? So it is resistant. Remember, resistant was the fancy way of saying outliers don't mess with it. Okay, so that's a good thing. A downside, but a plus side, is it doesn't directly use every data value. It doesn't care what this number below it is. All it cares is that there's a number below it. 50 is the middle, not because this is 51. 50 is the middle because there's a number above it. That 51 could be 55, and it wouldn't change the median. Okay? So it is resistant, and that is good, but it is also resistant, and that's a liability. Okay. All right, so how do you calculate one? Well, it depends on how many data points you got. Whether the number of data points is odd or whether the number of data points is even. If the number of data points is odd, the median is literally located exactly in the middle, like we did here. 3 is odd, it's right in the middle. If the number of data points is even, we find the 2 that are in the middle and we find the mean of those 2 middle numbers. Okay? There is no standard notation for the median, like we had X bar for the mean. These 3 are most commonly used. I'm a huge fan of this one. I don't like this one because I think that this and this are really similar when you're writing by hand. If you're typing it, yeah, those two are clearly different. But if you're writing by hand, a sloppy this could look a lot like that. And I wouldn't be able to tell, is that the median? So you won't see me use that in the notes. You might see it in a homework problem here or there. And M also, I'm just going to write up those 2 extra letters and call it the median. Right? That's where I'm going to feel happy, and that's what I'm most likely going to do. All right, so let's look at an example. I would like to find the median of the first 5 data speeds for the Verizon data set. Okay, so here's my data set. I want to find the median. I'll show you by hand first. First thing I'm going to do is I'm going to order it from lowest to highest. So 14.1 and then 22.4 and then 23.1 and then, oops, 38.5 and then 55.6. There's my data set. There are 5 data points, so right there, that one is in the middle. N is 5. The formula for the median location is n plus 1 divided by 2. So if we do 5 plus 1 divided by 2, that gives us 3. So the location of the median is the third data point. So first, second, third data point. And there's our median. So we would say the median is 23.1 megabits per second. Okay? Now, what do I do if I have an even number? Well, here I got 6 data speeds. Okay? So now order them from smallest to largest again. 14.1, 22.4, 23.1, 24.5, 38.5, 55.6. Now, I have 6 data points, so my formula up there should say 6 plus 1 divided by 2, so that's 3.5. 3.5, I can't find a 3.5 number. So what that 0.5 tells me is it's somewhere between the third and the fourth. It's in the middle between the two. So first, second, third, fourth, fifth, sixth, it's right in between these two guys. So the way I'll find it is I will find the median by taking the mean of those two numbers. So I'll take 23.1 plus 24.5. I'll divide it by 2. So I'll grab my calculator. I've got 23.1 plus 24.5. Divide that by 2. And I'll get 23.8 is our median. Megabits per second. And I know what you're thinking. That's a lot of work. And it is. Because if I just go back here, look what's right there. That was these guys. That was those 5 numbers. There's our median, 23.1. I'm done. It finds it for me. The good people at TI expected that you would want to do certain things with data sets, and they built those certain things into the calculator. And it says, here's the fast way to do this. Oh, but you wanted to do this problem. Well, all we have to do is add one to our list. So if I go to Stat, Edit, and I scroll down to the bottom, and I add that 24.5 to my list, and then I go back to Stat, over to Calculate, Option 1. Now my median is 23.8. It calculates it for me. So could you find the median by hand? Absolutely. You can find the median by hand. And if the data set is small, might not be that terrible to do it by hand. If I gave you 50 data points, do you want to scroll through 50 data points to try to find the smallest and the second smallest and the third smallest and list it? Because I don't. I'm going to chuck it in the calculator, and I have the calculator find me my means and my medians. Our third one is the mode, but we're at 28 minutes, so I'm going to end this video here, and I'll start the second part of this one at the mode. See you for part 2.